In previous lectures, we have discussed some preliminaries required to understand the electromagnetic field theory. Now, we are going to discuss the main topic of electromagnetic field theory, that is the electrostatic. So, let us start the topic electrostatics. In this discussion, we are going to see the Coulomb's law and its representation in mathematical form. Then we are going to see the Coulomb's law in vector form. Then we will see or we will study the electric field intensity. So, let us start the electrostatic, which is the first lecture of electrostatic here, that is part 1. Here, to study the electrostatics, mainly we need to know two laws. One is the Coulomb's law, another is the Gauss law or the Gauss law, because the electrostatic itself stands on only these two laws. So, first let us understand the Coulomb's law, or let us see the Coulomb's law. The Coulomb's law says that the force F, capital F, the force F between 2 point charges Q1 and Q2 along the line joining them directly proportional to the product of Q1 and Q2 and inversely proportional to the square of the distance r between them. Therefore, mathematically we can represent the Coulomb's law as F is proportional to Q1 Q2 by r square, which is presented in equation 1. Now, as F is proportional to this Q1 Q2 by r square, so we can write F equals to K into Q1 Q2 divided by r square, where K is the proportionality constant. Let us see that one. So, here equation 2 shows that F equals to K Q1 Q2 by r square. Now, here K is called the proportionality constant, and the value of the proportionality constant K depends on the choice of the units or choice of the system of units. Suppose we have Q1 and Q2 in coulombs and this distance r in meters, then we will find the force that will be in Newton. So, it depends, the value of K will depend on the choice of the system of units. So, another point here, we know that it is known to us that K equals to 1 by 4 pi epsilon naught. This is given in equation number 3. Now, this epsilon naught is called the permittivity of the free space and its unit is in farad per meter. Permittivity in free space. What is the meaning of the permittivity? Permittivity means how much it can penetrate, the electric field can penetrate into the free space, that is the permittivity. And we know the value of epsilon naught is that 8.854 into 10 to the power minus 12, which is approximately, we can write 10 to the power minus 9 by 36 pi farad per meter. Now, if we put the value of epsilon naught in the expression 3, we will get that 1 by 4 pi epsilon naught, that is equals to almost equals to approximately 9 into 10 to the power 9, and its unit is given meter per farad. So, as we got the value K equals to 1 by 4 pi epsilon naught, we can represent the F in terms of this 1 by 4 pi epsilon naught, that is given here. Finally, the Coulomb's law, F equals to Q1 Q2 by 4 pi epsilon naught r square. Now, that is the expression of the Coulomb's law in scalar quantity. But how to represent this Coulomb's law in vector, that is also we need to know, because mostly whenever we are going to study the electromagnetic fields, that is the vector, electromagnetic field is a vector. So, here also we need to know how to represent that Coulomb's law in vector form. So that is why we have considered the Cartesian coordinate system. In this coordinate system, we have 2 point charges q1 and q2, and the position vector of the q1 from the origin is r1 vector, and the position vector of q2 is r2. Now here we want to find out the force on this particular charge q2 due to the electric field produced by the charge q1. So that force on q2 due to the q1 charge, suppose we have written here F12. So to find out the force F12, what we need to do, we need to draw the line joining q1 and q2. So that distance between q1 and q2 we are considering is r12, which is a vector. So now we can write using the Coulomb's law that force F12, you can see that the force, because this q1 and q2 are in same polarity, so the repulsive force will act on that, so the force will be in this direction. So F12 will be equals to that is vector q1 into q2 by 4 pi epsilon naught into epsilon naught r square r12 square into the unit vector a r12, and its direction will be along the direction of F12 from the point of q1. So here you can see that we have written F12 equals to q1 q2 by 4 pi epsilon naught r square ar12. Now ar12 is the unit vector. We can represent this equation 5 in different form. Why we are representing this equation in different form, we will see afterwards, then it will be clear. So ar12 can be, we can find out, and before going to find out, we need to find out r12. It is the vector. So this r12 can be calculated as vector r2 minus r1. You can see that if you consider this is a triangle and it is along this direction arrow, so this the r1 is moving in this direction, r12 is in this direction, and r2 in this direction. So we can find out r12 equals to r2 minus r1, because r1 plus r12 will be equals to r2 small r2. So this r12 will be equals to r2 minus r1. So here we got r12. So from that we can find out the magnitude of this r12, that is mod of r12, that is equals to mod of r2 minus r1. So as we got the mod value of r12 and the vector r12, then we can find out the unit vector ar12, that is r by mod of r12 by mod of r12. So that we can write r12 by r. So now we need to find out r12 by r square, because we need to replace this ar12 by r square, this term. So ar12 by r square will be equals to, if just multiply here, so r12 by r cube. So ar12 by r square can be replaced by r12 by r cube. So here it is replaced, f12 equals to q1 q2 by 4 pi epsilon naught into r12 by r cube. Now this r12 we know r2 minus r1, so we can replace that one, and r cube, that can be written as mod of r2 minus r1 cube. So this is the final expression of F12 if we consider 2 point charges, and if we want to find out the force on the charge q2 due to the electric field produced by the charge q1. Now in the opposite side we can calculate the force on q1 due to q2. Again you see that the force on q1 due to q2 we can also find out. Here the force will be F21, but interestingly in this case we can easily find out as we got the expression of F12, because it is in the it is in opposite direction of F12, but the magnitude of the force will be same as F12. So if we got the expression of F12, then we can write F21, which is equals to the magnitude of F12, that is mod of F21, that is will be equals to F12, but the unit vector will be in the opposite direction, that will be equals to minus of or a r21 or minus of a R12. So that we can see here. Here you can see that F21 will be equals to F12 mod of F12 because the magnitude will be same into AR21. But we know AR21 is in the opposite direction of AR12. So here F12 into minus of AR12. So that will be equals to minus of F12. Since AR12 equals to minus of AR21. So we can write easily, F21 equals to just minus sign we have to add, that is minus of F Q1 Q2 by 4 pi epsilon naught divided by R2 minus R1 by mod of R2 minus R1 cube. The equation is same, here only the negative sign present, F for the case of F21. Now from the Coulomb's law, what conclusion we can make, that is written here. You can see that the first point says the like charges repel each other while the unlike charges attracts. That we know, that if plus and minus q charges is present, then the attraction force will act, and if the both charges are in the same polarity, then the repulsive force will act. Second point says the distance r between the charged bodies q1 and q2 must be very large compared to the dimension of q1 and q2. In a nutshell, we can say that q1 and q2 must be point charges, because if the distance r is very large, then the dimension of q1 and q2 will be very less. That we can consider q1 and q2 is the point charges. And third point to be concluded of the conclusion is the charge q1 and q2 must be at rest. And the fourth point here is that q1 and q2 must be taken as for like charges, q1 and q2 will be positive greater than 0, because we know q1 and q2 if positive, it will be always greater than 0. For unlike charges, it will be always negative, because if q1 is positive, q2 is negative, then also it will be negative, so it will be less than 0. If q1 is negative, q2 is positive, again it will be negative and it will be less than 0. So these are the conclusions we can make from the Coulomb's law. Now we are going to consider another condition. Suppose instead of 2 point charges, we have n number of point charges q1 to qn present in the Cartesian coordinate system. So apart from this n number of q charges, we have another point charge q. Now we want to find out the force on that particular charge q due to the n number of point charges. So to find that, we need to know the position vector of the all the q charges, q n number of charges q1 to qn. So here the position vectors of q1 to qn charges is taken as r1, r2 up to rn, and the position vector of the q charge on which the force we are going to calculate is taken as r, simply r. Now how to calculate the force on the q charge due to the n number of point charges? So the answer is we are going to use the superposition theorem to calculate the force on the charge q due to the n number of point charges. So here you see that for the force on the point charge q due to q1 can be written as, you see that, is same formula, q into q1 into r minus r1 divided by 4 pi epsilon naught mod of r minus r1 cube. And now the force on F2 on q charge due to q2 charge, here q into q2 into r minus r2 divided by 4 pi epsilon naught mod of r minus r2 cube. Similarly for the nth charge, the force on q charge, it will be q into qn into r minus rn divided by 4 pi epsilon naught mod of r minus rn cube. So if we take the summation, then you can see that q 4 pi epsilon naught, it will be common, so q by 4 pi epsilon naught summation of k equals to 1 to n qk into r minus rk by mod of r minus rk cube. That is the equation number 9. That means we can find out the force on a particular charge q which is present at the position r1 r vector from the origin. Position vector of this q is R, and the force on that Q charge due to the bunch of point charges, n number of point charges we have considered, we can calculate using equation number 9. Now we are moving to the next part of this discussion, that is the field intensity. Now what is the field intensity? The definition is given here, the field intensity. The electric field intensity or the electric field strength, or more familiar, we know it is called the electric field. Actually, it is the electric field intensity, the electric field. So, electric field strength is the force per unit charge when placed in an electric field. Now, again, you consider the charge present is Q and its position vector is R prime. We will see afterwards. Then we have the unit on that coordinate system, and suppose its position vector is R. So from that also we can, using Coulomb's law, we can find out the electric field intensity, that means the force on that unit charge, that is the electric field intensity. So mathematically we can write E equals to F by Q. Here Q is the unit charge. So unit charge, to calculate the unit charge, Q must be tends to 0, or simply we can write E equals to F by Q. Here Q is the source charge and which is producing the electric field. For that the force is acting on the unit charge. So equation 10 is representing the field intensity, electric field intensity. So here you can see that in this expression, a Cartesian coordinate system, Q charge, the source charge is present and whose position vector is R prime, and one unit charge is present at this position P and its position vector is given R, and the distance between these two charges is capital R. Now we want to find out the force F1 on that unit charge. So to find out this force on the unit charge, we can use the Coulomb's law. So before going to use the Coulomb's law, let us see some points here. For Q greater than 0, if the Q is positive, then the electric field intensity will be directed along the direction of the force. That means the force direction and the electric field direction will be in the same direction. But if Q is negative, then the direction of electric field intensity and the direction of force will be opposite. Now from the graphical representation, we are going to calculate the force or the electric field intensity on that particular charge or the unit charge. Here you see that the force F equals to the multiplication of two charges, Q into 1 divided by 4 pi epsilon naught R square AR. Now F equals to Q by 4 pi epsilon naught R by R cube, that we have seen in the case of Coulomb's law. Now this E actually will be, because it is the unit charge, this unit charge is divided here in this left hand side of the equation. So F by 1 is Y F, that is the electric field intensity. So E is the electric field intensity, which is equals to Q by 4 pi epsilon naught into R by R cube. So ultimately we can write Q by 4 pi epsilon naught R by R square. Here R vector can be calculated is R minus R prime. We have seen earlier in the case of Coulomb's law. So here the value of R can be calculated as R minus R prime. So AR will be R by mod R. So AR by R square is R by R cube. So finally the equation 1 shows the electric field intensity E, which is equal to Q into R by R prime by 4 pi epsilon naught mod of R minus R prime cube. Here this Q, you always remember, this Q is representing the source charge which is producing the electric field or electrostatic field, and on that electrostatic field we are placing one unit positive charge, and the force on that unit positive charge is nothing but the electric field intensity. So this is the electric field intensity. Now suppose instead of the unit charge we have the Q charge present. So we can write the expression. You can see that the force F equals to Q, that is the source charge, and here instead of unit charge we have considered Q. So Q should be multiplied here. into r minus r prime by 4 pi epsilon naught r minus r prime mod of r minus r prime q. So now this q should be divided here in this expression in the left hand side, that is the unit charge. To calculate force per unit charge, here the q should be divided, q should be here here, that is f by q we need to calculate. So f by q, which is equals to q into r minus r prime divided by 4 pi epsilon naught r minus r prime mod of r minus r prime q. Now again here we can calculate the electric field intensity for n number of point charges. Here you can see that the unit charge will be always 1. So using the superposition theorem we can calculate similar expression. E equals to q1 into 1 into r minus r1 prime not mod of r minus r1 prime q plus for q2 into 1 r minus r2 prime divided by 4 pi epsilon naught mod of r minus r2 prime cube plus here for nth charge qn into 1 into r minus rn prime divided by epsilon naught mod of r minus rn prime cube. So using the summation, find out electric field E or electric field intensity E equals to, here you can see that 1 by 4 pi epsilon naught sum of k equals to 1 to n qk into r minus rk prime divided by mod of r minus rk prime to the power q, equation number 12. So students, this is all about the Coulomb's law, how to represent the Coulomb's law in vector form. Then we have seen if the n number of charge present in a Cartesian coordinate system, what on a but other charge q charge for this n number of charge. Then we have seen that the electric field intensity for one charge. Also we have seen the electric field intensity of, due to the n number of charges. So thank you very much students, that is all today's class. Thank you.